Okay, hi everyone. Let's get it started. We have a lot of material for today. One thing I forgot to highlight a bit last week at the end was this. So we have been saving files at GPKG a lot, but one difference here was that we specified a layer. So this is, if you have worked with GPKG files, you already are familiar with this. So one way of understanding this is, if you have worked with ArcGIS before, you might be familiar with geodatabases. So geodatabase is it's not the same thing, but it can be thought of as a folder inside which you can have multiple data files. So GeoPackage is a bit similar. So inside it, you can have multiple layers. So in ArcGIS geodatabase, they're called feature classes. So you can have a geodatabase and then have several feature classes inside. In GeoPackage, you can have multiple layers. So you can just keep the same file and add different layers. And when you're reading the file, if you want to read a specific layer, the syntax is similar. You just specify the name of the layer from which you want to read. Okay, so if there are no other questions, comments, we can start with the contents of today. We're already more than halfway, time flies. So soon we will start to maybe already next week, because in 2 weeks we don't have a lecture because it's the Independence Day. So maybe next week, if there's time, we would briefly talk about the final assignment. Some of you might want to take a look at it already during that week that we don't have a lecture. But yeah, let's get back to that later, maybe next week. So yeah, so what we are going to talk about today, as the last couple of weeks, we will continue working with GeoPandas, also another library, and we will continue to do some of the most essential vector data analysis in GIS. So we will work with overlay analysis. We will learn to work with union differences of different geometries, and yeah, so it's a bit related to what we did last week with the spatial join and intersecting. So we will continue with that. We will also learn how to aggregate geometries in GeoPandas, and then we will also learn simplifying geometries. These are things that probably have done in GIS before. And then one bigger part we have today is about classification. We already took a look at this, I guess, last week when we were creating some map. So today we will open the topic of classification a little bit more. Yeah, so that was the introduction. Let's get started with the contents of today. So let's go to CSC as usual. If you haven't pulled the changes yet, please do so now. Yeah, so you should have 4 folders here. Lesson 4 should be added. Yeah, so we are going to start with overlay analysis. Okay, so overlay analysis are GIS operations in which 2 or more vector layers are combined to produce new geometries. You probably have done this a lot in your work so far. So some of the most common operations that you see or you use a lot in GIS are the ones that you see here. This is just an image taken from QGIS documentation pages. You can follow that link and read more about it. So very often we need to get the examples here are from 2 polygons, but of course you can have more than that. So very often we need to find the intersection between 2 polygons. As you can see in the image, it's the area that the 2 share. So it's the area where they overlap. So if you perform an overlay and if the operation you choose is intersection, that green areas is what you will get as the output. Very often we need to perform union, which is basically it's a union. So if you have 2 polygons, all the areas covered by the 2 polygons will be included in your output. Then we have difference. So here the direction matters. So if you have two polygons, one of them is called A, the other one is B. So A minus B will give you the areas of the polygon A which are not covered in polygon B. And the opposite would be B minus A, which would give you the areas in polygon B which are not covered in polygon A. So like you can see here in this example, another operation we have is symmetrical difference, which is kind of the opposite of this. So yeah, so it's the union of the two polygons except the area that is shared between them. So this is a bit less often used. At least I haven't had much use for it, but it exists, so you can use it if there is a need for it. So yeah, so as you can guess, in today's exercise, in this part of our lesson, we are going to practice some of these. So did you all manage to get the latest lesson to your notebook? Did you pull the changes? Okay, good. So what we are going to work with is a data set that we have already seen during this course, and you probably have heard a lot about it. It's this data that we have produced here in the Department of Geography, the DigiLab. So it's this Helsinki region travel times, this matrix that you have seen before. So in this first part of our lesson, we want to do an overlay. So this is from Helsinki region, so it's a bigger area. We also have the polygon of only Helsinki. So what we want to do now is to do an overlay and only extract the areas that are within the polygon. So the two data files that we have, and they are stored in this folder, data. One is this matrix, so it's a big grid from Helsinki region, and then we have this Helsinki municipality border that we would work with. But as usual, let's start by setting the paths to our files. Then we are going to read the two files that we have. The code is already there, so let's just run that. You will probably get this warning. It doesn't matter. If you run it again, it will not show up. Okay, so before we get started, let's take a quick look at our data. So this is something we have done a few times. Let's plot the two layers on top of each other and see what it looks like and what we want to do. So let's create a new axe, and then we will add our grid data using the dot plot method. And let's choose gray as face color. Let's also add the polygon of Helsinki municipality to the same plot. So Helsinki dot plot. So we are going to use the same axe. Let's choose the face. Let's set the face color to none. So we just want to see the boundary. And the boundary color, let's set it to blue or whatever you like in your case. Yeah, so this is the data that we are going to work with. Well, at this zoom level, you're not going to see the grids, but this is a grid data, so there are a lot of small grids here. And then we have this polygon, so what we are going to do is to extract this area where the two data, data layers basically intersect with each other. So as you can see, this is a very large data. We have over 13,000 grids here. So as I said also last week, when we are doing anything to do with overlays, it's important to check the coordinate system. As I said, like when you use software like QGIS or ArcGIS, they do some kind of check for you, so it's not as big issue with many of these things. But remember that when working with Python, things are a bit more raw, so you should make sure that the coordinate system is the same so you don't get any issues. So let's check what coordinate system we have in our Helsinki data. So let's print helsinki.crs. Yeah, so this is the coordinate system that most of us are familiar with if you have done analysis in Finland. So let's make sure that the other data layer that we are going to work with is in the same coordinate system. And as usual, we are going to use an assertion to check that. So assert helsinki.crs. We want to see if it equals greet.crs. And if it's not the same, you're going to type this message, print this message, CRS differs between layers. Okay. So we didn't get any warnings, errors, so that's good news. It means the coordinate systems are matching, so we don't need to change anything. So now that everything seems to be fine, we can go ahead and do the intersection. And doing that is quite easy. So let's create a new variable where we will store the output. Let's call it intersection. So for doing overlay analysis, you just write greet.overlay. And then here you provide the other data layer that you're working with. In our case, it's Helsinki. And here you have to specify the operation that you're using for doing the overlay analysis, and the parameter for that is how. So you just provide a value for how. And here you put the name of the operation. In our case, we are going to do an intersection now, so you just type in intersection, but you can use anything from any of the operations that are available to us. Okay. So now we ran the code. Now the intersection should be done already. To make sure everything is okay, let's create a plot. So intersection.plot. And for color, I'm gonna use blue. So as you can see, we did the intersection, so we got only this overlapping area here. Let's also take a look at our data. So intersection.head. Yeah, so you can see that the few columns are added. So based on the intersection, like the names have appeared, the new columns have appeared from the other intersecting data. Yeah. So that's the good thing. Not only we clipped our data, but also we got the attribute tables merged. So now we go ahead and save our output. I'm just going to go and copy this text. Yeah, so this is something we are going to work with later today. So let's save it here as travel time matrix Helsinki region. Okay, so that was pretty simple. Do you have any questions? If not, let's continue with the second part of the lesson today, and that's aggregating vector data. So before reading this, do you remember what is aggregating vector data? What do we do when we aggregate vector data? So very often for me, like before when I was doing, like I was newer to GIS, I always confused aggregating and merging. So they're different things. So merging is like, you know, you just add new rows or columns to your data, and now we have learned that it's quite easy with pandas. You can just add new rows to your data. In GIS, we always have some tool called merge for that kind of purpose. But aggregating means that you have data on a small, like for example, you have the data set collected on a city level from all cities of Europe. So it's about, I know, for example, about the income, different kinds of socio-demographic characteristics of different cities around the Europe. So you want to aggregate this data into bigger units. So for example, you don't want to make a map based on cities, but you want to make a map based on countries. So you can aggregate it to country level. Or you might aggregate it to a bigger level, Europe, and then you can create a map of different continents. So this is basically what we do with aggregation. So don't confuse it with merging or anything like that. So we are going to continue working with this travel matrix that we already started working with. So as you can guess, for when you're doing the aggregation, you need to have a way of telling your software, or in this case Python, that okay, based on this column, put them together. So getting back to the example of the cities in Europe, and you have the income information from them. So you should probably have a column in your data called country. So you know that, okay, Helsinki is part of Finland or Tallinn is part of Estonia. Then you use that column to aggregate them based on the countries. So you need to have that kind of column for aggregation. So in this tutorial, now in this part of our lesson, we will aggregate our travel time data by car travel times. You can read more about this data. The link is provided on the website, but if you check the metadata, you will see that this column is named car underscore R underscore T. So basically we want to put the grid cells together that have the same travel time to the railway station. So this is from travel times to railway station, so the center of Helsinki. So let's work with the file that we just created. So let's run this code to get the path set to our data. Then we go ahead and import our data. So for doing aggregation, we use a method that is called dissolve. So it takes an input column from you as the input of the function, and based on that function, based on that column, the values in that column, it will do the aggregation for you. So let's create a new variable and call it dissolved. Then we are going to dissolve our intersection data. And here you have to provide the name of the column for which you are, based on which you are doing the aggregation, and the keyword for that, the parameter for that is by. And then you pass in the name of the column as string. So in our case, it was called car underscore R underscore T. Let's also add dissolve.head here so we can take a look at what our data looks like. Yeah, so it is done now. So everything looks okay. So now we have dissolved some of the grids into each other, so it makes sense if we have less features in our data. So let's check that. So the code is already written here. So we are printing the number of rows of data in the intersection, which was the original file we started to work with, and then dissolved. So let's see how that has changed. So originally in our intersection data, which we got from the first part of lesson, we had almost 4,000 rows of data, and now after aggregating the data, we have only 51 rows in our data. So now let's take a look at the columns in our data. So dissolve.columns. Yeah, so do you see anything that draws your attention here in the name of the columns? Do you notice any column missing from here?
There isn't card warranty.
Yes, exactly. So the column that we used for aggregating is now missing from our data. And do you have any guess where it might have gone? Yeah, exactly. So what has happened here is that the column that we used for aggregation, now in this new geodata frame we created, it is used as the index. That's why it doesn't show up when you use .columns method. So so let's check. Let's confirm that this is the case. So let's get dissolve .index to see what is our index. And yes, that was the case. So the column that we had used for aggregation is now used as the index. Which is, depending on what you want to do, it might be good or not. Like, it is good if, for example, you want to get now all the grid cells which are 15 minutes away from railway stations. So because now the time is used as index, so you can just easily get that row. So it's just dissolved .log, and here we just put 15 because 15 minutes is just used as index, so it should work. So do you have any guess what is the format of our output? So what is the type of output we got here? So you can see the name of the columns appearing here. So what we got out is basically one row of our data, and you remember that when you have just one row, it's just a series. Here we don't have. So let's check that it is the case. So type, then dissolve .log. Let's check it again with the 15. Yeah, so it's a panda series. As you can see, it's just one row of your data. Yeah, so now we want to work with it. So, and for example, create a plot from it. So we need to convert it back to a geodata frame. Then we can create a map from it. So let's do that. This is something you have done also in your exercises. So let's call this selection because it's based on the selection that we did, so the name makes kind of sense. And then we use GeoPandas, which we have earlier imported. GeoData. So let's go and type this again. Log 15. And we specify the CRS. CRS hasn't changed, so we just use it from the dissolved file. Dissolved.crs. So now if you run that code, it should have created a geodata frame from that row of your data. So now let's go ahead and create a plot to see what the output looks like. So we create an axis, usual axis. And let's use gray as the face color. Then we add the selection that we have just made on top of it. So selection.plot. We use the same axis to add it to the same map. And to make it look different, we use a different face color for it. I'm going to use red. Yeah, so this is the output. Now it looks right. So these are areas, the grids, which are 15 minutes away from railway station in Helsinki. So like we have seen before, another more usual way of visualizing this is to just use the column name. So in our case, now that column we want to visualize is used as index. So we are going to go, first we are going to release that column from our index. So in order to do that, we can just reset the index. So it will just create a new index for us, and the column that we have now, this car RT, will be released, which we can use for visualization. So let's use the variable dissolved. So we just use reset underscore index. Let's also take a look at what the data would look like after using .head method. Okay, now you can see that it created a new index for you, starting from 0, the default value, the default index for pandas data frames. And now your column is released, so this car RT is back in the list of the columns you had. So now that we have the column released, let's try to make a map from it. So dissolve.plot. Now we use this column for visualization. Car. Yeah. And this is the output. So aggregating data using GeoPandas is fairly easy. Just remember that whatever column you use as a column for doing the aggregation will end up being your index. So if you need to work with that, if you don't want it to be your index, then you can just reset the index and use it. Yeah, okay, so I guess, did we miss one step? Yeah, we have no values. No values are marked -1. Yeah, yeah. So it's not minus, it's just missing data. So it's marked 1. Yeah, I guess in the next step we will remove the missing values.
When dissolving, what happened to the other columns? Like for example, the flighting travel time. Did it just get averaged?
Yeah, that's a good point. Yeah, so that's another thing with aggregates. So very often you want to calculate some kind of a statistics based on that. So by default, it will provide averages. So it will get the average of the columns for other columns. Yeah, but you can also specify what kind of a statistics you want to get calculated. Yeah. Okay, if there are no other questions, let's continue with the next part, which is simplifying geometries. This is quite short. Okay, so probably you remember what is simplifying a geometry. So sometimes the shape of some polygon, some line is very complex, and for whatever purpose you have, for example, you want to make a map and you don't need all the details, so you want to simplify. So what we are going to, the example we are going to work with here is a river. Yeah, so it's the Amazon River from South America. So it is a very long river and it has a lot of details that are in this data. So we don't want all the details for whatever reason. Maybe it doesn't look so good on our map and we don't need all them details. So in most GIS software, we have a tool called Simplify or something like that. So you can achieve the same thing very easily using GeoPandas. So let's get started with this. So as always, we specify the path to the data, and then we are going to import GeoPandas and read the file. So the file is saved, it's a GeoPackage file, so Amazon River. So let's read the file and look at the head. So we just have one line which represents the river in this case. So let's take a quick look at the coordinate system that is used in this data. Probably it's very different than what we are used to working with here in Finland. So it's Mercator 2SP with 2 standard parallels. Yeah, so this is the coordinate system, probably suitable for that part of the globe. What is important for us is the unit here, that is in meters. We are going to get back to this when we are applying the simplification. But before we simplify the river, let's take a look at what it looks like already before we simplify it. So let's just do amazon.plot. So this is how the river looks like. As you can see, there's a lot of details here that we want to get rid of. It's a line string. Yeah, so now let's go ahead and do the simplification. So the way we do this, well, this is a functionality that comes from Shapely. You remember from already first lecture that we worked a lot with Shapely. So Shapely gives you a lot of functionalities when you're working directly with geometries. So this is what we are doing now. We are working with the geometries directly. So let's just use so we will use Shapely and we will apply simplification directly to the geometry column we have in our data. So this will create a new column, a new geometry column in your data. So we should give it a name. We are going to call it simple geom. So it's the simplified geometry. So what you need to provide here as the input for simplify function is a tolerance that is in meters. So very often you have to use trial and error to see what it looks good for your purpose. I've tried this before and 20,000 meter works well. This is why we needed to check the coordinate system. So because this is the same unit as the coordinate system. So it's in meter in our case. So if it was in kilometers, instead of 20,000, you would have written 20, for example. So that's why you need to check. So tolerance is the only input you need here. And we set it to 20,000. So what will happen here? Well, let's run this. And also look at the head. So when you run this, you can see that there is a new column added to your data, to your data frame. So now you have two geometries. So you can choose either of them to create your visualization. So geodata frame doesn't know by default which one should be used. So now in order to tell GeoPandas that, okay, we want this other column for visualization, we have to set our geometry. And in order to do that, so we create a new variable, and then we set geometry to this new geometry column that we just created. So set geometry, and here we provide the name of the geometry column as string. So it was called simple geom if you have used the same name as me. So now this is telling GeoPandas that, okay, I have more than one geometry columns, but this is the one I want to use for visualization. So now if we go ahead and create a plot of our geodata frame, it should use this new geometry for visualizing. Yeah, so now we use this new geometry for visualizing, and as if you compare it with the image, with the plots we had earlier, we have a lot less details in the shape of the river, in the geometry of the river. Yeah, so it's quite easy. Just remember that it creates a new geometry, and in order to visualize it, you have to specify to GeoPandas that, okay, this is the geometry that I want you to work with. For example, if you're creating a map based on this simplification. Okay, any questions from this? Yeah, so this is quite easy. Let's continue with reclassifying. This is a bit longer part of today's lesson. So reclassification is something that is again very familiar for you. If you have ever created a map, you have probably used some kind of classification. So in your work you might do reclassification for a number of reasons. Most often why we do it is for creating some kind of map. So imagine you're creating some kind of thematic map. You have numbers, you're using that, you have numbers, for example, you have numeric values in a column, and you're using that to visualize things. So one way of if you have a lot of numbers, you often want to reclassify them put them into classes so your map looks nice. So that's a very common case of using reclassification, but also you can use reclassification for other purposes. So you might want to just add a column to your data and classify your data rows based on some criteria. So one example here, like we are going to work with something similar to what is written here during this lecture today. So imagine you want to, well, you have access to this travel matrix that we have worked with already today, and you want to choose suitable areas for your home. So you want to rent an apartment. So you have a criteria. You want it to be within a certain distance from city center. So let's say you want it to be within 30 minutes from railway station in Helsinki center, but also you have a limited budget. So you don't want the rent. Well, of course you can live in city center and your rent is probably very high. So the second criterion you have is that I don't want to pay more than 1,000 euro rent. So you define this kind of criteria, and based on this you can classify your data rows. So then you can identify which which rows, which grid cells in your data are potentially suitable areas for living, meaning that it's close enough to center for you and the rent is not more than 1,000 euros. So these are some of the examples of where you might need reclassification. So what we are going to work with in this part of our lesson is to, well, there is a Python library called PyCell that you can see here. It comes with a sub module or sub library called map classify that comes with a lot of built-in classification methods. So if you want to just, very often we use some of these common classification methods, so you can see the examples here. So in QGIS, in ArcGIS, we often use Jenks method or natural breaks. So these are built-in. So if you're just creating a map, there is no point in just, well, these are based on some algorithm, some optimization approach. So if you want to just create a map, it doesn't make sense to develop your own classification. Of course, we can do that. We will do it later today. But it's good to know that all these are already built in. So many of the approaches for classification that you might need are already available to you through this library. So this is a library. It's a rather large library. This PyCell is short for Python Spatial Analysis Library, I think. So it's a major spatial analysis library. With GeoPandas, we do a lot of like basic GIS analysis, but PyCell is more specialized for spatial analysis. So if you want to do like a statistical and spatial statistics or this kind of an analysis, it's a good library to check out later. Yeah, so for our case, we are going to just use it for creating our classification in this part of lesson today. Yeah, so in the first part, well, we are going to try different kinds of these classification methods that are readily available to us, and then later we are going to learn how to create a custom classifier. So a bit similar to the example we had here, that we want it to be close enough to city center. So this is the criteria, but also we have a limit. We don't have data on prices, so we cannot check the rent if it is 1,000 euros, but let's assume that if you are not too close to center, probably the rent should be a bit more reasonable. So this is the criteria that we are going to use. So it has good public transport accessibility to center, and also is further to center than a certain value, assuming that it will affect the price and it will be within our budget. So let's get it started. Again, let's specify the path to our data. The code is there, so let's just run it. We are going to work with this matrix again, this travel time matrix, which has the travel time to railway stations. So let's just read the data, and it already has the dot head, so we can take a look. Yeah, so this is the data that we have worked with already today. It has a number of columns, different kinds of measurements, distances, time with using with different travel modes. So very rich data if you need to work with it in future. So now we want to do some of these classifications that are readily available to us. So as one of you noticed already in the first part of the lesson, there are a lot of -1 values, which are the missing values. Earlier we didn't bother to get rid of them because we were not really analyzing the data, just showing things. But now we are doing the classification and that would mess with our results. So let's go ahead and remove those. So no data is -1, so we are going to just get rid of anything that is smaller than 0. So the code is already written there, so it's just basically checking that there is no -1. So the condition is that it's bigger than 0, equal or bigger than 0. Okay, so now this should have, by this we probably got rid of the -1 in our data. So now what we are going to do, we have tried it already last week, and that's creating a visualization. We are going to create a thematic map, and in that we use a classification. So we did it last week, but let's try it again now. So we create a map based on the accessibility grid. So let's use the plot function. So accessibility underscore grid dot plot. Yeah, so the column that we are going to use for our visualization is called PTRTT, which is the travel time with public transport to Central Railway Station. So we specify that as the name of the column. So the name is PTRTT. The scheme is the parameter using which you will specify how you want to classify your data. So this is made possible to you through the PySal library, but if you're just using it in your visualization, you do not need to import it. You just use some of the name of the method. So now we are going to try to use natural breaks, which is a very common classification method in GIS. Another thing you need to specify is the number of classes you want to have, and the parameter for that is k. So you just provide a number for k, which is the number of classes you will get after classification. So in this case, we want to go with 9. As you have probably made maps before, you know that, of course, you need to have a good understanding of your data, but also very often you need to try different values to see what works best for your data. So in our case, 9 seems to be the magic number. So what we are going to do now is to apply a color ramp. So we saw last week that there are a number of color ramps already ready to us, so we can use different shades of color. What we are going to use is RD, R should be capital, RD YL blue. So this is a common color used in thematic maps. So it ranges from red to blue through yellow. So it's red, yellow, blue, as you can tell from the name. Then what we are going to provide is the width of the line. So line width equals 0. We don't want to make the map very crowded, so let's just get rid of the outlines. And then it's nice to have the legend, so let's set legend to true. Yeah. We are going to, I guess it's already next week, we are going to work with visualization, so we will learn more how to make cool maps using GeoPandas. But let's run this. So as you can see, it takes a while to run because we are not only making a plot, but we are also at the same time reclassifying our data. So depending on how large your data is, this might take a few moments. So this wasn't so bad. And this is the output. As you can see, it has reclassified our data using natural breaks into these classes, and it has applied the color ramp that we chose. So it ranges from red to blue through yellow. And we have 9 classes. So one thing to notice is that if you run this many times, well, depending on what classification method you're using, some of them, depending on the method, some of them have some element of randomness in part of them. So it's an optimization approach. So if you run this many times, your outcome might be slightly different. So that's because of how the algorithm works for classification. So don't get surprised if you get something slightly different. So the result of the map is not very surprising. You can see that the travel times are, well, shorter the closer you are to the city center. So it's dark red here, and then we have more blue, like longer distances, travel times further north. So now let's make another plot, and based on walking distances. So accessibility grid. So this time we use the column walk underscore D. So it's a walking distance. Let's again use natural breaks as the scheme, as the classification method. So we just put natural breaks. Then we need to specify the number of classes we want to have in our data. And then again, we need to provide the color ramp. So let's use again the same color. So it was red, yellow, and then blue. Let's do it similar way. We don't want outline for our polygons, so line width 0. And then let's add a legend to our map. Again, it will take some time because we are doing the classification at the same time.
So where does the scheme come? Now there's the natural break. Is there like a list? Like
Yeah, we had it earlier here. So you can use any of these. And if you just check the specifications of library, you can see the exact word you should use. So they have a page on, they have a GitHub page, so they have examples of different approaches.
Oh, okay, I see now.
Yeah. Okay, so I got my output. I guess you should have gotten it by now as well. So this is based on travel distance. It's not time anymore. So as expected, we have this like radial pattern. So of course, because the further you are, the longer walking distance you have. So the result makes sense. So this was one way of applying the classification to your while you're doing visualization. So it's your purpose of doing the classification is purely for making a map. There's no point in like running classification first and then creating a map. But sometimes you want to have it in your data. For example, you want to do some kind of analysis based on that. So now we are going to work with that and see how we can apply it directly to our data. And also we will work a bit more closely, more specifically with this library that I said. This is what is providing us with those classification methods. Just practice this a bit. Yeah, so this was the library we were using implicitly for doing the classification. Now we are going to work with it a bit more. So let's just import the library first. So let's do some classification without creating a map. So we just use map classify, which is the name of the library we are using, then dot natural breaks in our case. So we are going to try natural breaks. And then you have to provide a variable called y. So it's the column that you're going to create a classification based on. In our case, it's from our data accessibility grid. So we are going to use the column we used earlier, PT, RTT. And then again, you have to provide the number of classes you want for your classification. So now you see you didn't use it in a visualization, it just created the classification for you. You can see that these are the ranges it created for you, and these are the number of counts of rows of data you have in each of these bins of data, bins of values. So you can try different methods for this. Let's just practice a few of them. So I'm going to just copy this line of code and try it with quantiles. So we are using the same column. The method is different, so I'm going to replace this natural breaks with quantiles. So as you you probably noticed that we don't need to provide the k value here because it's quantile. So it's going to give you 5 classes. So sometimes you do some kind of classification, and depending on what kind of work you are doing, you might need to access these thresholds that the classification is creating for you explicitly. So in order to do that, there is a .bins method, but let's try that one. So let's do the classification again. So we create a new variable called classifier, and we use this map classifier library again to perform a natural breaks classification of the same column again. So we specify, so Y is again accessibility grid, and the column's name was PT RT. And let's go with k equal 9 again. So in order to access these values, that's thresholds that we saw up here, you can just get classifier.bins. So as you can see, as the output, you get an array where you have these values. So you have the values stored there. So it's a list. So if you want to access one of these values, you can just access it using the index value of the list. Yeah, so let's try to add the classification to our data. So what we did so far, the first example, we just used it in the map without changing anything in our data. In the second example, we just did the classification again. We didn't change anything in our data. Now we are going to add it to our data. So in order to do that, you have to first initiate the classification, and then you use a make function to initiate the classification, and then you can apply it to your data. So let's initiate the classification first. So we create a new variable called classifier, and then we use this map classify library again. Again, using natural breaks as the classification method. And one thing we add here is this make function. And then here you still need to provide the number of classes you want for your classification. So now the classification is initiated using the criteria you have defined. So you said, okay, I'm using natural breaks and I have 9 classes. So what you can do is now just apply it to your data. Yeah, so let's create a new variable called classifications. So the column we want to apply the classification to is the same column we have worked with. So PT, R, TT. And then we use this apply method. This is something you have worked with a bit before with pandas. And then you apply this classifier which you defined, which you initiated earlier. So let's run that. Let's also take a look at our data to see what it looks like. So classifications dot head. So now you can see that you have a column added here. So it's the classification values. We are going to look at this a bit more closely, but let's look at the type of output we got. So type. So now we have a data frame as the output. So the output has the index value. It's a new data frame. And what it has just given you is the classes you have created. So you have created up to 9 classes. So you probably have values from 1 to 9. And these are like, here we can see 8 and 7 from the first 5 rows. So it's a data frame that we are very well familiar with. So it is probably more useful for us if we create a classification and instead of a new empty data frame, we just add it as a column to our original geodata frame. So let's try to do that now. Yeah, so let's use this accessibility underscore grid. So now we are going to create a new variable. So it's based on the name of what we had earlier. We just add NB at the beginning. You can choose what you want. But I put NB like natural breaks, so it's the same column we had. The rest of the name is the same, so R, TT. So this is a new column name, so you can choose whatever you want. Doesn't have to be this one. So here we provide the original column, PT, R, TT, and then again we apply the classification that we had initiated earlier. So I just created a new cell. Let's look at our data. So accessibility grid.head. So now you can see that you have your original geodata frame. The only thing that has changed is that you have a new column, which we just created here, and that has the classification values. Was it clear? Yeah?
So it doesn't replace the PTRT column.
It doesn't replace, it just adds a new column. Yeah, yeah. So that one is also somewhere in the beginning probably. Yeah. Yeah, the original one is there. So now that we came this far, let's also create a map of our data. So accessibility underscore grid. I'm going to create a plot based on this new column we created. So column name is this new column we just created, which was in my case named NB underscore PT RTT. I don't know about you, but I don't need outlines in my case. It will just make the map messy. So I'm going to put the line width to 0. And I want a legend, because what does a classification even mean if you don't have a legend? Yeah, so this is the output. So we just created so like I said, now we wrote quite a few lines of code. We did the classification, then we created the visualization. That's why if you just want to visualize, if that's why you are creating the classification, you don't need to go through this. You can just do it through plotting. So yeah, so as I said, in order to choose the right number of classes and also a good method of classification, it's important to know your data. One way of getting to know your data is through visualization. So it's often useful to create different kinds of plots that can help you understand your data distribution a little bit better. One plot that is particularly useful when trying to classify your data is a histogram, and that is quite easy to make using the dot plot method of pandas. So let's create a histogram of our data. So I'm going to use this accessibility grid data again. And you provide the name of the column based on which you are going to create the histogram. That's the TT. Then .plot.hist, which is short for histogram. And one thing you need to provide here is the number of bins you want to have. Bins is these boxes that you have in your histogram. Once we visualize it, you will see better. So I'm going to put 50 as the number of bins and run the code. So this is our histogram, and these are, I won't count it, but probably we have 50 bins here. Yeah, so just to, for the rest of this part now, the code is there. We just want to visualize the lines. So with natural breaks, with those different classification methods, what we basically did was we identified breaks in our data, and we did the classification based on that. So now with this piece of code here, we are going to add those thresholds that we identified with classification as vertical lines to our map. So we are doing the classification. We have already done this part. So using natural breaks, we are having, we want 9 classes. And then we create the histogram. This is what we have done so far already. And then one thing we are adding here is we are going through the bins in our classification. Remember, we saw this earlier. When you do the classification, you can access those thresholds that you created in classification using .bins method. So we are going to go through each of them using a for loop because we have 9 classes. So we go through them either manually, which would be not very wise, or through using a for loop. And we are going to add this vertical line with this line, this plot.axv line. So it's going to add a vertical line, and we want the line to be black and dashed, and you can specify the width of the line. So let's run this. So this is what we created. So we just basically added this. So this gives you some understanding of how the classification has worked. So it's a useful thing if you are using classification in your work. Let's do the same thing, but this time based on quantiles. So the code is the same, it's just the classification is different. It's quantiles. Let's run this and see how the classification works. So yeah, so the classification is different. We have 5 lines here, and they are placed differently. So you have all done GIS before. You know that depending on what classification method you use, the output, the map you make can be very different. So that's why it's important to choose it properly. Yeah, so you can practice more. Well, you will get to practice this in your exercise, but also here you can try the same things with a different column, but we don't have so much time, so I will continue. So far what we have done is to use those readily available classification methods. So we use quantile, natural breaks. So what if you have your own criteria? So let's get back to the example of finding a home for us somewhere in Helsinki. So this is the criteria we have. We want a grid cell where the travel time is lower or equal to 20 minutes. So we want it to be we have good access to city center, and we don't want the home. And we want it to be more than 4 kilometers away. So as I said, we don't have price data here. We just assume if it is 4 kilometers away from center, it's probably within our budget. So let's do that. So doing this is fairly easy. So it's just a conditional statement. So here we are checking that based on this travel time column, we are checking that it's less than 20 minutes. And then based on walking distance, we have another conditional statement checking that it's bigger than 4,000 meters. So if we just run this, well, it's a conditional statement. It's going to give us a Boolean output. So it's saying that it's false. So now we tried it for the first row of our data just randomly to test. So for the first row of our data, wherever that is, it's not a suitable place for us to look for home. So what if we want the output to be numerical? So now we get the output as false and true. How would you turn that to like 0 and 1 if you want to have it binary? Any suggestions? You can use anything you want for your classification. Well, let's say I want to use numerics. 0 and 1. So it's easy. You just put int before it. So you just convert the output to integer. So let's try that for another row in our data. So I'm going to copy this text so I don't have to type it again. But I'm going to change the row for which I'm testing this. So I'm going with 11293. I'm using this because I know it's true. The output is true for that cell. So we want to just see another example. So it's 11293. So in order to get 0 and 1 as the output, so if I just run this, it's going to tell me that it's true. It meets my criteria, so I might be able to find a home there. But if I want to have it as like 0 and 1, like binary output, I just pass the whole thing to int as a function. So what it does, it just gives me 1. So 0 is false, 1 is true. There might be cases where you might need that. Okay, so now what we want to do is that, well, what we are doing is quite simple, and there are many ways of doing that. So now you have a criteria that you are going to apply to all the rows in your data. So what we want to do is to just go through all the rows in our data and check if our criteria is true or false. So, and then write it to a new column in our data and store it. Like that would be like, so the column that we are using is suitable area. So it's either a suitable area where we get the value 1 or true, or it's not a suitable area and we get the output 0. So there are different ways of doing that. Of course, one way of doing this is to write a for loop. But we have seen before, if you, have, for example, have a large data set, this may not be the most efficient way of doing things. Another way of doing this is that we define our criteria as a function, and then we apply that function. We have seen in pandas that you can apply a function. You can go through rows in your data and apply a function, like we did earlier with classification. So that's another way of doing that. So for doing that, you need a function. So you can either define a function. We have done that before in the first course, GeoPandas. But in this case, you are probably just defining a criteria only once, and you're just doing the classification once. So it doesn't make sense to just write the code and define a function if you're only using it once. That's why in Python there is a very handy tool called Lambda. I don't know if you have used it. This was in the hints of, I guess, the first exercise. Did any of you end up using this? Yeah, so great. So we are familiar with that. So instead of defining the function and just wasting your time and effort, and well, now memory may not be a problem with new computers, at least on our scale of work, but it's not a good practice. So you can just create this quick function that goes through each of the rows, and this is what we had written earlier. So this is just the condition. So what it does is basically, this is just a made-up temporary function we have applied that goes through the rows. So the row is input here, and this returns the output of this, which is 0 or 1. So this is the same condition we defined earlier. And it goes through all the rows in your data. So it applies it to the rows. So does this make sense?
You should replace that row with that column if you want it.
If you want, yes, yeah. Yeah, so if you just put x is 0, for example, you will go through columns. In our case, we are going through rows, so yeah. Yeah, so let's just run this. And let's check our data by using head function. So accessibility grid dot head. Yeah, so now we can see we have created a new column here, this suitable area, and it has either 0 or 1. Like in these cases, these first 5 rows, they're all 0, so they're not suitable areas for us. So we just did the criteria, we did the classification based on our own criteria. We didn't use natural breaks or anything. So you can do that for your work, which is good. So let's look at our data and see how many outputs we got that meet our criteria. So one nice way of doing this is using the value count. So let's go through the column, accessibility. So we are going through the column we just created, which was named suitable area. And what we are going to do is to count all the numbers we have there using this function or method. So value counts. So if you just run this, it gives you that. So you can see that we have 13,000 rows of data which are not suitable for our case. We only have 9 cells within Helsinki region that meets our criteria. So let's create a plot and see where these 9 cells are. The code is already there. Let's just run it. Okay, so It's somewhere here. So we have only 9 cells that meet our criteria. Do you have any questions? Or? So if there are no questions, you can quickly have a look at our exercise for this week. By the way, how are the exercises going? Is it like easy to follow the exercises? Is it too much, too little? At least there hasn't been complaints lately, so I guess there is some balance.
It's been good.
Yeah.
The workload has been okay.
Yeah, that's good. Yeah, so as usual, we have the classroom. Again, we don't have auto grading, so we just grade you manually. So let's have a look at GitHub where the exercise is. So we have 2 problems that we are solving related to what we worked with today. So now in the first problem, we are going to join the accessibility data with the grid network that we have. So we practice joining that we learned already last week, and then we create some visualization. So you, as usual, you read the grid cell, you read the data, you do a join between the 2 layers. Then you do a classification based on a criteria that is defined here. So you will have your, we will have the user-defined classification. So it's custom method, and then you create a plot based on that. So very similar to what we did today, just different data. Even the data is similar. So in the second part, we calculate and visualize the dominance areas of shopping centers. So we do a bit more calculation here. So it's quite fun exercise. You get to do a bit like proper GIS here. So yeah, so you measure the area of dominance of the shopping centers based on a certain distance, and you create some visualization based on that. Yeah, that's it. Do you have any questions, any comments? If not, that's it for today. See you next week. And maybe next week we'll talk about the final assignment. Yeah, have a good evening.